Right, Year 4, welcome to today's numeracy lesson. So I'm going to go through a PowerPoint with you first, and then there is an assignment available for you to do at the end. I'll mention a few optional extras which you've added onto the lesson, which might help you really get to grips with the 11 and 12 times tables. So today's ELO is to learn the 11 and 12 times tables and use them to solve division problems. So when you do a times table, if you do it, you can use the same facts to do a division problem, and that might sound a bit complicated to some people, but don't worry, I'm going to explain it. So our first optional activity is something on Sentry which you can use to warm up your brain or to make sure you understand your 11 and 12 times tables. You can do it now if you'd like before you get started, or you could do it before you do your assignment. So all you need to do is log into Sentry, and it will be under this title that you can see on this page, Optional Warm-Up Task 11 and 12 times tables. Okay. Right, so as I said, we're looking at the 11 and 12 times tables. I know you looked at the 11 times tables yesterday, and some of you might have noticed there is a pattern to the 11 times table, as you can see here. There is a really clear number pattern in the 11 times table until 9 times 11. Children sometimes think that the 11 times table is going to be really hard, so when they see a pattern, it's a big relief. And you can see here, this is the pattern. So the pattern is you repeat the number that is being multiplied by 11. So you can see 1 times 11, you repeat that 1, so it's 1, 1, which is 11. 1 times 11 is 11. 2 times 11, you repeat that 2, is 22. So 2 2's 22. 3 times 11, we repeat that 3, 33. 3 times 11 is 33. And so on and so on. And you can see it's nicely colour-coded, so it's really easy for you to see it on this page. This pattern stops once you reach 10 times 11. But hopefully all of you know now how to do 10 times a number. You generally, if it is a plus number that doesn't have any decimal points, you just add a 0 onto the end. So that is the case here. 10 times 11, we add a 0 onto the end of the 11, and that makes it 110. And then if we're doing 11 times 11, we know it's just 11 more than 110, and so forth and so forth. So 12 times 11 is 11 more than 11 times 11. So you can use your addition here until you learn your times table facts off by heart, which hopefully by the end of the year we will all be able to do. And trust me, it's really, really helpful in a lot of maths as you go forward. If you'd like to have a little bit longer to look at this times table pattern, you can pause the video here, maybe write it out yourself in some nice coloured pens to put up on your wall. Right. Now this is another optional activity for you to do, so if you want to pause the video, you can pause it here. This optional activity shows how you can see a pattern. So count in 11s and colour in the grid. You'll be able to see quite easily that the numbers go across. So 1 times 11 is 11, 2 times 11 is 22, 3 times 11 is 33, and so on and so on. It will go all the way down here till 9 times 11. Okay, and then we have these questions here. These are just getting you to have a little look and make sure you understand how to do it. So 2 times 11, as we said, the trick is that you double the number you're timesing 11 by. You have 2 of them in a row, so it will be 22. 12 times 11 is a little bit trickier. The answer is 121. 5 times 11 is 55. 6 times 11 is 66. 7 times 11 is 77. And 9 times 11 is 99. Right, now we are having a look at some different ways to represent sums. This will be shown in your tests all the way up to your GCSEs and probably even A-levels, there's different ways to have a look at sums. So this one here, you can see each line is 11. And we know we're doing our 11 times table, so we know one of these numbers, there or there, it doesn't actually matter which direction, which one it is in, needs to be 11. And it's going to be 11 times the number of blocks we've got. So 1, 2, 3, 4, 5, 6, 7, 8. So 11 times 8 or 8 times 11. And we can do that in our heads, which we know would be 88. And we can check it by counting each individual square and adding them all up. So I'll give you a second to do the next two. You can pause the video if you want to do these by yourself and haven't already. Okay, right, now I'm going to give you the answers. So again, we have blocks of 11, so we know either that number or that number is going to be 11. Then we need to count how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 times 11 or 11 times 9, and the answer is 99. And our next one, on to C, we have 3 lots of 11, so it's 11 times 3 or 3 times 11, and the answer is 33. Hopefully that's got your mind warmed up and you're remembering your 11 times tables again. Right, now we're going to talk about using the inverse. So that means changing the way a sum looks. So you could do this with pluses and minuses, but we're going to have a look at them with dividing and timesing. Okay, so 22 divided by 11 equals 2. We can then see, we can use all of those numbers again if we're using the times tables. So because we know that 22 divided by 11 is 2, that means 22 split between 11 people, every person has 2. We then know that 2 times 11 is 22, or 11 times 2 is 22. You can see that these are basically the same sums, we've just swapped those the other way round. And again, very similarly, 44 divided by 11, so if you have 44 cupcakes and 11 people, you give them out equally between everyone, everyone gets 4 each. Because we know that fact, we can then tell that 4 times 11 is 44, or 11 times 4 is 44. And again, we've just swapped those numbers around. The sum is exactly the same, they're just in a different order. And you can see that here more clearly. So 11 times 1 is 11, or 11 divided by 11 is 1. We're still using all the same numbers, we're just shifting the direction they're in. 11 times 2 is 22, or 22 divided by 11 is 2. And so on and so on. If you want to examine that for a little bit longer, you can pause the video now. Right, now we're going to move on to our 12 times tables, because we're also having a little look at them today. So pause the video here if you would like to have a go at your 12 times table. Right, so count in 12s and colour in the grid. You should have coloured in 1 times 12 is 12, 2 times 12 is 24, 3 times 12 is 36, 4 times 12 is 48, 4 times 12, 5 times 12 is 60, 6 times 12 is 72, and so on, all the way down under the 12. Okay, 4 times 12 we can do by counting down. 1, 2, 3, 4 is 48. 8 times 12, 1, 2, 3, 4, 5, 6, 7, 8 is 96. 5 times 12, 1, 2, 3, 4, 5 is 60. 6 times 12, 72. 7 times 12, 84. And 9 times 12, 108. And this is very similar to before, apart from each block has 12 in it. So we know either that number or that number, and so forth, is going to be 12. Doesn't matter which way it goes around. I'll give you a second to do that. If you'd like to pause this now to give those a go, you can pause it now. Right, so our answer is going to be 12 times how many sticks we've got. 1, 2, 3, 4, 5, 6, 7. 12 times 7, or 7 times 12. And we'll already have our answer up here. And then here we're going to go 1, 2, 3, 4, 5, 5 times 12, or 12 times 5, and our answer is 1, 2, 3, 4, 5, 60. And the other way to check it would be to count each individual ones of these squares. And it should add up to 60. And C, we're going to have 12 here or 12 there. And 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times 12. 1, 2, 3, 4, 5, 6, 7, 8, 9. So our answer should be 108, and you could again check it by counting each individual one of those, and it should add up to 108. Okay, now we've had a little bit of time to practice our 12 times tables, we're going to just have a look at the inverse again. So this is again, we can see that all the same numbers are needed. So 24 divided by 2, if we have 24 sweets and we have 2 people, they will get 12 sweets each. If we have 2 times 12, that will equal 24. Or if we have 12 times 2, that will equal 24. So we've just swapped those numbers around, but it's actually really the same sum. And again, 108 divided by 9 equals 12. Or 9 times 12 equals 108. Or 12 times 9 equals 108. And just like we had with the 11 times table, we can see here how that works. So 12 times 1 equals 12, or 12 divided by 12 is 1. Okay, all the same numbers are in play, but because we're dividing, we're swapping the numbers around. Pause here if you'd like to examine this, or maybe write it down if you find that helpful. Right, now using the knowledge that we have learnt, using the inverse, we can have a little go at this mastery question. You can see the first one has been done for you. So we know that 9 times 5 equals 45. But now because we are doing dividing, we need to bring the 45 round to the front instead of as the answer. So that's the first thing you need to do with all of these. So our answer down here, we're going to move 288 to this box and this box. Here we're going to do 595 to this box and this box. Here we're going to put 323 in that box and that box. Here we're going to put 306 in that box and that box. And here we're going to put 442 in this box and this box. Then we need to add in these other numbers. So there we could put 18, there we could put 16, and then the alternate number, so if we put 18 there, 16 will go there. If we put 16 there, 18 will go there. Give that a go. See if that makes sense to you. Don't worry, we'll come back and do a little bit more of this style of question. I'm just trying to get it into your heads that we still need the same numbers if we're swapping them around between division and multiplication. Right, now it's your time to give the sheet on your assignment a go. Challenge yourself to complete 2 levels, so mild or hot and spicy, whatever you feel like. Have a look at them first and see, ooh, maybe I could do hot. Oh no, that looks quite difficult, maybe I'll do mild. We shall give you feedback on what you submit to the assignment. Good luck everyone, I hope that makes sense, and I will talk to you again later today.